Now let's look at some examples. Example 1, given that f of x is equal to x cubed minus 3x squared minus 2, find and classify any stationary points. So we're looking for maximum and minimum points. So the first step, which is step 1, we need to find the first and second derivative. So find the first and the second derivative. Okay, so the first derivative here is 3x squared minus 6x, and the second derivative is 6x minus 6. So step 1 done. Step 2, what we need to do is to find the critical points. So find the critical values of x by setting the first derivative equal to 0. So what that means is we need to set the first derivative equals to 0, and our first derivative is 3x squared minus 6x. We equate that to 0, which means we need to solve this equation. We can solve it by starting, okay, we can factorize out 3x. So we'll end up with x minus 2 is equals to 0, which means that either 3x is equals to 0 or x minus 2 is equals to 0, which means either x is equals to 0 or x is equals to 2. So those are the critical values. Step 3, what we need to do now is use the second derivative or apply the second derivative test. So step 3, use the second derivative to determine the maximum and minimum points, which means we are going to plug in these critical values into the second derivative. So we can go ahead and say at x is equals to 0, okay, the value of the second derivative, so you just plug that into the second derivative, and that will be negative 6. And this means that this is a maximum since the second derivative is less than 0. Okay, from the second derivative test. And then at x is equal to 2, the second derivative will be equal to, again, you plug that into the second derivative. So that will be equal to 6. And you can say this is the minimum since the second derivative is greater than 0. So it's the opposite of what you expect. And then step 4, what we need to do now is to find the y values. Okay, find the y coordinates. Okay, so we need to find the y values, so which means we just need to plug in 0 into the original function. The original function is what you had in the beginning, f of x, this guy here. So you need to plug in 0, and that will be equal to negative 2, which means that the maximum point is 0, negative 2. So you have the coordinate of the maximum point. Okay, and then the same applies to 2. You plug 2 in the original function, get negative 6. So the minimum point is 2, -6. Okay, remember you have to plug this x values into the original function. Okay, next example. Given f of x is equals to this function, find and classify any stationary points. So the first step is we need to find the first and second derivatives. So step 1, find the first and second derivative. Okay, the first derivative is so the first derivative will be equal to 15x to the power 4 minus 15x squared. The second derivative will be equal to 60x cubed minus 30x. Okay, and then step 2, find the critical values. So find the critical values of x by setting the first derivative to 0. So what I'll end up with is my first derivative is 15x to the power 4 minus 15x squared is equals to 0. Factorize out 15x squared, you end up with x squared minus 1 is equals to 0, which means that either 15x squared is equals to 0 or x squared minus 1 is equals to 0. Now here x will be equals to 0, but here we have difference of 2 squares, so x plus 1, x minus 1 is equals to 0, which means x is equals to -1 or x is equals to 1. So those are our critical values. Step 3. So step 3, use the second derivative to determine maximum and minimum. So use the second derivative to determine maximum and minimum. Okay, so what that means is at x is equal to -1, you plug that into the second derivative because now you're applying the second derivative test. Okay, so just plug that into the second derivative here, and what you end up with is -30, which means that this will be a maximum since the second derivative is less than 0. Okay, and at x is equal to 1, the second derivative will be equal to, if you plug that into the second derivative, you will end up with 30. So this is the minimum since the second derivative is greater than 0. Okay, how about at x equals to 0? At x is equals to 0, the second derivative will just be equal to 0. So, and which means that the second derivative fails. Okay, and previously we discussed that if the second derivative fails, we need to apply the first derivative. Hence, apply the first derivative. the first derivative test. Okay, so what's the first derivative test? It means that we need to go onto the number line. Okay, we need to do this. We need to go to the number line, and this is the values of x. So we have 0 here, and we need the signs of the first derivative, not the second derivative. We need the signs of the first derivative. So we need to pick test points. Okay, so on the left of 0, we can pick a test points like that's close to 0. So negative a half, and here we'll have positive a half. Okay, so if you plug negative a half into the first derivative, this one here, the first derivative there, you'll end up with negative 45 over 16. You can use your calculator for this, and this will be negative 45 over 16 as well. And these signs are negative and negative. So we can see here that from this to this sign diagram, f dash x, or the slope does not change. Okay, so f dash x, or the first derivative, does not change sign, which means at x is equals to 0, the original function has no local maximum or minimum. Okay, so at x equals to 0, I'll just make this clear. So at x is equals to 0, the original function has no local maximum or minimum. Step 4, which is finding the y coordinates. So find the y values of the point. Find the y values of the points. So what that means is we need to plug in negative 1 in place of x in the original function. So if you plug in negative 1, what do you end up with? That will be 2. So we can say, and this is where the maximum point is. So we can say there's a maximum point at negative 1, 2. Plug in 1 as well. So if you plug in 1 in the original function, that will be negative 2. So that is minimum point at 1, negative 2. If you plug in 0 in the original function, you'll end up with 0, which means there's neither a maximum or a minimum at 0, 0.